Two examples where pyroclastic flows have been completely devastating are Mount Pelée eruption in 1902 and Mount Vesuvius eruption in 79 in the current era. Mount Pelée destroyed the whole city of Saint-Pierre in the Caribbean island of Martinique, as can be seen in the top two images. Only a few people survived this eruption, and these people were not actually in the city, but at the bay or in the mountain above the city itself. Mount Vesuvius's eruption, I should say, is more well known as the destruction of the city of Pompeii. This took place in the year 79 of the current era. For centuries before the event, the volcano had actually been dormant, but it only took about 24 hours for Pompeii to be completely covered by the ash and pumice, which killed all of the residents of Pompeii, which is located near Naples. This event was actually recorded by a spectator many kilometers from there, across the bay, if I'm not wrong. But now we have a better account of the events based on archaeological evidence and geological evidence, obviously. The city itself, Pompeii, remained covered for the 17 centuries after the eruption until archaeological excavation happened, which allowed for a reconstruction of those events. And it seems as though initially the city was covered in ash at a rate of 12 to 15 centimeters per hour for the first day, which probably means that most of the roofs actually collapsed by the amount of ash, which is very heavy. And then after this ash fall, a pyroclastic flow came rushing and engulfed the city, killing any potential survivors that had actually withstood the collapsed roofs or the suffocation from the previously fallen ash. So it must have been an incredibly awful situation to be in. And Mount Vesuvius has erupted about 25 times since then, and as you're seeing it in the picture on the lower left, it towers over the city of Naples, which currently has about 3 million people. So it's a little bit eerie to know that it can erupt at any point, basically, due its past activity, and that 3 million people have got to be evacuated somehow when signs of a possible eruption are about to occur, or is about to occur. Aside from the violent eruptions, sometimes these large composite cones may generate a type of fluid mud flow known as lahar. They occur when volcanic debris becomes saturated with water, and then it rapidly moves down the slope of the volcanic gradients, which are generally following some sort of stream valley. Some lahars are triggered when magma near the surface warms up the snow or ice-covered volcanic summit or near the summit, causing large volumes of these ice and snow to melt and hence run through those valleys as water that is saturated or is full of these rock debris. Others are also triggered when heavy rains saturate the weathered volcanic deposits that have been deposited before. Thus, sometimes lahars occur even after a volcanic eruption, so not necessarily during the eruption or short time after, but many months or even years afterwards, just by rain that has, been able to dislodge those deposits and hence become lahars. The image on the left shows lahars that occurred after a May 19th of 1982 eruption of Mount St. Helens. So it's not the same one as the 1981, but in this case you can see the lahars very clearly. Fortunately, the area was not largely populated this time, and after the 1980 eruption, there were also some lahars they were just not as easily recorded as in this picture right here. A very significant case for lahars and their destruction. It happened in 1985 after a small eruption of El Nevado del Ruiz, which is in Colombia. The pyroclastic material from the eruption itself melted the snow-capped mount and sent torrents of the saturated ash and debris down 3 major river valleys that through the flank of the volcano. These lahars reached speeds up to 100 kilometers per hour, and they reached the town of Armero in the department of Tolima. They destroyed much of the town, as you can see in the images on the right, and they injured many victims and completely claimed the lives of 25,000 people, who basically had no warning, or if they had any warning, was warning of remaining inside of their homes due to the potential ash that would be falling. These people were mostly sleeping, and this happened at night, so they had no warning nor any way to look at what was going on around them until the whole valley pretty much filled with this rock, debris, saturated mud flow. As you may recall, I am from Colombia, and although I wasn't born at the time of this event, my dad did help during this event. He was studying medicine at the time, and he assisted at Armero with many of the injured victims. Some of the most painful things about this event was not being able to rescue some of the victims who were still alive and searching for help. They were buried halfway through or more inside of the sediment that could not be excavated, and sediment mixed with water that couldn't be excavated near them because their organs might collapse due to the sustained pressure, or some of them may have just been buried by water, like the girl that you're seeing in the picture. Some of the sediment was accumulated towards her bottom half, but if they had pumped the water out, they might have been able to rescue her. However, due to the lack of response from the government, they weren't able to save her, and so she was, in agonizing pain for, I think, 60 hours, and eventually died of hypothermia after those 60 hours. The case of this girl indeed did touch the world, and so that is how the event, I think, reached many of the places worldwide. Many people consider that Mount Rainier in Washington is one of the most dangerous volcanoes, since it is almost always snow-covered, adding to the fact that about 100,000 people live in the valley around Mount Rainier. And many of their homes are built actually on sediments remaining from previous lahars, just like the town of Armero was, built on lahar sediments. Both of these maps that you're seeing in the picture are of the lahar hazards. One of them is showing the hazard and occurrence of lahars after the 1985 eruption of El Nevado del Ruiz, the one to the left, that happened in 1985. The second one to the right shows you the Mount Rainier's possible aftermath if this was to be an eruption in fact. So you see that the lahar hazard zone, which is the yellow bands, reaches many of the smaller villages that have been built in previous locations of lahar deposits. So definitely a big risk for the people near there. Alright, so here I'll mention some of the other hazards associated with volcanic eruptions. Some of them or one of them is tsunamis, although they're mostly associated with faulting in the seafloor, as we'll see in chapter 9. If a volcanic cone collapses and a great deal of the volume from the collapse plunges into the sea or in a channel of sorts, a tsunami could occur. As was the case, for example, in the 1883 eruption of Krakatoa Island in Indonesia. So Krakatoa was not habited, but the cone collapse itself plunged into the Sunda Strait, and it caused a 30-meter tsunami that reached um, Java and Sumatra Islands coasts, and it killed about 36,000 people. So tsunamis can happen if that's the type of case. Also, volcanic ash clogs engines of airplanes. So, for example, in the last 20 years, at least 80 commercial flights have been affected to some degree. Volcanic gases may occur, and they are also very harmful. So, as I told you, some of the volcanic gases that are erupted are not sulfuric acid, but SO2 and other poisonous gases. SO2, for example, reacts with the moisture in our lungs when we breathe it, which makes sulfuric acid. So HO2 plus the SO2 creates the sulfuric acid, which is toxic. This happened, for example, in Iceland after the Laki eruption of 1783. There were many deaths of livestock and people across Europe due to this eruption. And it is thought that if something similar were to happen today, it would probably take the lives of 140,000 people just from the cardiopulmonary causes in Europe alone. Another thing that can happen is cooling overall in our climate for a short period of time, or a relatively short period of time, geologically speaking. So volcanic eruptions eject these dust-sized particles of ash and also SO2 into the atmosphere. Both of these particles reflect the sun rays back to space, which produces a temporary atmospheric cooling, not allowing for the sun rays and its warmth to get to the surface. And major eruptions, like the Laki eruption in Ireland in, again, 1783, or for example, the Mount Tambora eruption in Indonesia in 1815, or El Chiclón in Mexico in 1982, it's been recorded that the local and even the global climate for the season or the year to follow has had lower temperatures than average. Lastly, and not surprisingly, there can be roof collapse with ashfall, and there can be destruction of homes, fences, roads, whatever it may be, with lava flows.